Yeah, cool. So let me see. So now you see a very fancy business room in a hotel with just nothing around. Oh my God. So yeah, well, how to explain the guys from the hotel that not connected to a radio server is an issue that I can't solve. Okay, so I hope the sound is not too crappy here in this cave.
No.
Okay.
I can clearly hear. That's better.
Sounds like a good plan. Yeah. So sorry for being late. So and if I'm talking weird things, hey, come on, it's 4 a.m. So and I not even got a coffee. So
okay, next time you are coming to Turkey, we will serve you before your session a Turkish coffee, and we will go to outside Istanbul and make a trip around Istanbul. Okay?
That sounds like a good plan. Sounds like a good plan. Oh my God. So okay.
By the way, sorry, I want to introduce the you know this tool, GoToWebinar. We made a before. There, our audience can ask questions in the question section, and we will forward it from the chat area also to you. So you can check the chat area. Also, we can ask the questions at the end of the
yeah. So just what I see is that my mobile with Twitter is working, but it's a business thing, so I don't have Slack there on this with all the channels. So if you can forward by Twitter, it would be perfect. Okay, if I see it here somewhere in GoToWebinar chat. Oh, I have chat here.
Yeah.
Chat and questions. I have questions in chat. Should work. Very cool. Okay.
Yeah, if you want to just read, you can also check the chat area, so we can forward the questions to you.
Yeah, chat area is good as well.
Yeah, the break is now okay, so we can start to the your talk.
Yes.
So stage is yours.
Okay, so everything is running. PowerPoint is running. Finally, I'm ready to go. Okay, should we start?
Please go ahead.
Okay, so good morning, everybody. Good morning, because for me it's 4 a.m. I'm near the Mexican border in US, and this is why I needed a small break because the network was just not working at this time here in the hotel. So sorry for inconvenience, but you got a small break. I will try to start now and finish exactly at the right time. I think I have until 10:02, so we have enough time. I will talk a little bit about cybersecurity, DevSecOps topics. Excuse me?
Before starting, this is a presentation mode. Can you make full screen, please? And you have time, don't worry, after your session, there will be coffee break. You can take your time.
Okay, so let's see. So I have here now.
This is speaker.
We just see the slides, not see the presentation full in a full screen, let's say.
Oh, okay, let me see. I have this presentation mode. Let me start again. Yeah, technical issues. PowerPoint is my friend. So let's see. And again, we will get it. So, okay. Presentation mode, full screen. Let's say full screen. Okay. And main screen. So it should see everything. So
yeah, we can see everything now.
Okay, okay, so I'm closing all this stuff. I'm saying start here. So now you should see everything. Okay, because I'm seeing now nothing anymore. It's just my own slides. Okay, so finally, after all these technical issues and my excellent work with PowerPoint, so now we are ready to go. So what I want to talk about, I want to talk a little bit about the quick wins of DevSecOps, how to integrate in DevSecOps. It's more or less a little bit bound to the supply chain security topics that's right now really a big thing. So because we can see several things, I will go through this during the talk. Yeah, so I just will start with something that happened in the near past to use this as an excuse what we are doing right now and why it's influencing the global market. So even in a way that small and medium business size companies around the globe now have to deal with something that happened in US. And yeah, so this is one thing. I want to explain a little bit the mechanics, what's behind. I want to explain a little bit what open source and other tools you have to deal with this situation. And yeah, so in the end, you will have all the bits and bytes in your hand so that you can start working around this topic. But for sure, you have to adjust everything a little bit to your personal needs and your project needs and possibilities inside. So yeah, so let's see. By the way, my name is Sven. I'm from Germany, normally, right now near the Mexican border in this in San Diego, but mostly I'm running out in the woods. And if you want to see some stuff from me, you can follow me on Twitter, LinkedIn, as well as on YouTube. I have 2 YouTube channels, a German one as well as an English one. So make sure that you're selecting the right one for you. And there I'm running out in the woods and talking about DevSecOps topics. So if you're interested, I really would like to see you as my new subscriber. It's a young channel. It's a tiny one, but it's a fun project. So what happened in the past? So there was a SolarWinds hack. I don't want to go into all details because I think that most of you heard about it already. I just want to highlight the main things that are important for us as software developers. So the SolarWinds hack, for everybody who wasn't able to follow this one, or it's like there's a software company that built some software, and the software is managing networks. So customers of this company, for sure, if you buy software to manage networks, you have not only one server, you have hundreds, maybe thousands of servers, because otherwise this software makes no sense. So the software is somewhere in your network on central places and is managing this thing, means that this software has high rights like an administrative account. And so because it's able to manage resources, monitoring all this stuff. So what happened now? This company that's building the software, they have a CI environment, and the hacker group, yeah, they hacked the network. They searched for the CI environment, and inside the CI environment, they not destroyed something. They have done it very silently. They changed the build configuration. They changed the build configuration in a way that with every new build binary that was produced out of the original sources was compromised. And yeah, so they built the next version. This was a compromised one, the company, and then distributed to all customers. The big thing is that this company has over 300,000 customers. It's amazing. Yeah, 300,000 customers. 300,000 customers that are managing networks. It means we are not talking about 300,000 servers. We are talking about 300,000 potential target networks. Okay, so during a few days, they infected, I don't know exact numbers, but 15,000, 20,000 customers, something like this. So 15 to 20,000 networks, something in this area. And this was more or less a disaster. Okay, so what happened? The software started a few backdoors, loaded dynamically code, have done a lot of shit. And the big thing here is that mostly to get rid of it, you really had to shut down your whole network and start from scratch. Even sometimes buying new hardware because you're not sure where this software was really implemented. So, but what does it mean? For us as software developers, okay, that was a fancy attack and we are reading about it, smiling a little bit, ooh, this is a hot thing. And then I started thinking about, oh man, that's shit, because I'm not only attacked by consuming malicious stuff or vulnerabilities and all this. No, I'm the target of distributing it, even in a small environment. Now we are talking about the supply chain security thing. Where am I? Why I'm attacked? Yeah, I'm a multiplier. So I'm multiplication for them. So I'm distributing to something that is scaling. And so we as a software developer, we have to fight now against two directions. One is that we are not consuming stuff. Okay, we have to protect ourselves. And on the other side, we have to protect all others that are consuming our stuff. And this is something that we really should have in mind, that this changed over the few years, and it's dramatically changing right now because attacks are sometimes really fragmented over different parts of the supply chain, so that there is a big picture that I'm really hardly able to see, because if I'm not watching on or looking at the whole supply chain, I can't see all the bits and pieces that are bringing together the whole attack vector. But okay, nevertheless, so for me, short answer is I have to make sure that I'm not consuming stuff, and I have to make sure that I'm not distributing stuff to my customers. Customer could be an external company, customer could be in other department of the company. So what's supply chain security? So I mentioned a few things already, and it's dramatically changed over the last, let's say, 1 year. Because this supply chain means supply chain in general is a description of everything that is involved in producing something. And yeah, so every process, every human, every tool, every material, everything. So supply chain security in general is something very generic. It goes over all the industries, automobile industry, healthcare, whatever. So all everything where some process is running. Okay, so. And what we can see in cybersecurity is that we have more and more different attacks that are changing compared to the last years. One thing is compromising geopolitics. I don't want to go into the actual things that are ongoing, but I mean, the most of you can imagine what I'm meaning. So it means if you are as a small and medium business company, if you're working in an environment that is delivering software to something that is used in a bigger scale, okay, I'm developing something that's used by a company that's producing stuff for some other government or whatever, then finally, I'm not attacked by individuals, I'm not attacked by a hacker group. If I'm really unlucky, I'm attacked by other governments, okay, and this is the scale. We can see during the last, let's say, 1 year, that's going more and more. So this politically oriented stuff that's really here not motivated on earning money. So there are other targets. And this means I have to fight against huge infrastructure environments, and this is changing the world. Criminal adapts hustle and diversity. So it means you can see inside this ecosystem of groups that are taking different systems, that these groups are more and more working together. So what early days, it was more or less a competition between groups, and they try to make fancier things, but now they start sharing, cooperating. So they're sharing infrastructure, they're sharing information, they're sharing resources in terms of an expert is moving to another group, working there for a dedicated thing, moving back to the original group. So it's really, they're working more and more in a global scale. And this is something that makes attacks more and more sophisticated, more and more. Yeah, so it's really high quality stuff there. Expanding motives for ransomware. So I mentioned it indirectly already. So cyber attacks, let's say a few years ago, was mostly motivated for money. So they wanted to have some kind of money. They pay to destroy something industrial wise. They wanted to earn some money, and this ransomware was more or less, yeah, I crypt your stuff, give me money, and I'll give you the key. All done. So a lot of companies started thinking about, okay, this value chain part has a value of 2 million euros, and yeah, we have 2 million euros. So if they want to have this money, we are just paying, so we don't have to protect it, because over the years we are spending more money, so we are just spending this money. And if it is less, then we are just destroying it, building it from scratch, because the value at this part, this value chain, is just a value of, let's say, 1 million euro or whatever. So more and more we see that this encryption stuff is used really to destroy. So they don't want to have money, they just want to have it encrypted. And this is something that's changing a little bit the strategy of bigger companies with money. Improved ecosystem hygiene is pushing threats up to the supply chain. Means we have more and more this connection between the big companies and the small and medium business size companies. So if I'm in a company with, let's say, 20 people, and I'm working for a huge organization, so my big customer that's feeding me, it's some big company. So the big company has a lot more resources and power to make themselves secure. And this means that the targets, or I'm more the target because I'm the weak part, and this is pushing more and more to the edge. So it means the big companies, they're pushing all the security threats out of their environment to us. Vulnerability in cloud hardware infrastructure is something the most people are thinking about cybersecurity stuff in terms of software, but we have attacks against hardware. It could be modified hardware that I'm ordering. So I'm buying hardware in a different country, and this is just modified. Okay, we have this already, so really hardware attacks, or we have bugs, vulnerabilities inside hardware that lets so that we have weak cloud infrastructure. So in shared environments, I can see who else is working on this machine. I can have access to the pure memory and so on and so on. So we have a lot of stuff. But for us as a software developer, we have mostly just something where we are focusing on. By the way, this picture is from the project SALSA, SLSA, and this is a project from the Linux Foundation. That's a documentation project, open source. And this will give you the overview of what is happening or what is a common attack against the supply chain. So for everybody who want to read more about it, not only my YouTube channel, you should subscribe, but additionally, you can have this SALSA project. It's really a good thing. It's an alpha state, but it's growing, and they have different things. Here, I want to just highlight the common attacks. And additionally to this, they have documentation about levels. They call it levels so that you can identify on what security level I am, what would be the next cool step or good step to improve my security. So it's more or less how to identify where I am, what should I do, and on the other side, a description, what are common attack vectors. So looking at this picture, it's a typical CI thing. So we have source threads, build sets, and dependency threads means we have attacks against the source code itself. We have attacks against binaries and how binaries are produced, and all the dependencies. Short story here is, if I'm pushing software to the supply chain, so to this part of the supply chain, make sure that you're always having a code review so that you are working against these people that try to modify or compromise the source code because they're leaving the company, they paid from someone else, whatever. So really, code reviews is a big thing to make sure that a lot of attacks are just not possible against source code. It could be in a way that, for example, there were attacks over sending patches over the official mailing list, open source projects, and so on and so on. So bypassing the code reviews, one attack, okay, you can do it with human or with mechanism or with processes. Compromising source control system is just, you have this Git server you're using, harden it, otherwise it could be hacked. So people are just modifying the source code there, sneaking in with bad commits and so on. But here, you can harden the instance itself. From the source code is mostly then grabbed by the build system. So what could happen, it's already a build thread, but based on source code means it happened with webmin, for example. You're grabbing source code from the original part, but the build configuration is changed, overlaying some new source code, and then the build mechanism is started. So it's an based on source code, but it's already built thread because it's during the build phase. Make sure that this is not possible. It's modified code of the source control. Compromising build platform is, you have some piece of software, so your CI environment. If you have a Jenkins, make sure that it's hardened, otherwise it could be compromised. I talked about SolarWinds Hack. After this, the binary that's produced is sent to the repository. Make sure that the path from the building infrastructure to the repository is secured. So you think about zero trust environments on all parts of the value chain here. And for sure, the repository can be hacked. Make sure that this is, and so on and so on, and then you're consuming the stuff. But if you're looking at this, what the software developer can do, or what should we focus? We should focus first of all our source code. Sure. Make sure that you have code reviews done. All the other parts is mostly Git server, build server, repository, make sure that this is secured. If you can secure it inside, okay, someone will do it. Otherwise, make sure that you're using certified or secured service. And what's left over? Left over is everything that's dealing with binaries. So it means using bad dependencies. So we have bad dependencies and we have vulnerabilities and vulnerable packages and all this stuff. So we have slightly different, but this is the main thing we developers should care of. Source code, what we are doing with this, and the binaries we are consuming. So what different parts of security we have? We have three main test possibilities and one runtime protection. That is the most or biggest area. And if you start reading about some security stuff, you're confronted with this. But what should you use? So the first is mostly the static application security testing. And as it mentioned inside the name, it's a testing approach, means inside the static context. So you have all bits and pieces, you have access, you have a scanner that's scanning all the binaries, all the source code, all configurations, and try to get as much as possible out of the static semantics to identify things. So it's perfectly for non-vulnerabilities, detecting 0 days and all this stuff, because you have access to 100% of the components, but nothing must run. So you're losing parts of the dynamic context of an application. So covering this one, for this is mostly this dynamic application security testing. It means you're ramping up some part of the application or the application itself. Then you're looking from outside. It's more or less this hack approach. You try to attack your system with most common vulnerabilities and fuzzying stuff to see if something's going wrong. So you have some services out in the field that try to hack your system with SQL injections and all this stuff. Then people thought, okay, if I have a static application security testing and the dynamic application security testing, I can combine it because both have pros and cons. For example, the con of dynamic application security testing is, first of all, you have just no knowledge about the technology, really. So you have to modify the attack vectors based on technology. If you try to hack this is not easily doable if you have different services that are running from outside. So you have to do it by yourself, if possible. So tooling is not easy. On the other side, you can just do it after something is created already. So something's ready to go, and that means you spend already some time. So people thought, okay, the next thing is we are integrating both, and it's called interactive application security testing. Something imagining it like security debugging. So you're ramping up the component, you have access to all components, you're scanning this. At the same time, you're running an attack vector against this running piece of code, and you're debugging inside, so seeing what's happening and then start modifying all this stuff. For this, you need a huge amount of experience. So if you start with security, forget it to start with interactive application security testing. It's just, you must be highly skilled to do this. Otherwise, you're just doing crap. And then it's runtime application security protection. So that's not testing technique anymore. So it's just a technique mostly on agent based, so they're modifying it like a profiler, the application, checking what activity is inside the application. This is just possible on production because all other states are irrelevant for this part, because RASP is just there to identify there's an ongoing attack. Then it's, you have more or less two possibilities. So just to alerting, and the other thing is that sometimes these tools can really deactivate parts of the application if they identify an ongoing attack vector. So these are the biggest 4 parts what you should do. So you as a developer, where should go? RASP, definitely not, because running in production makes no sense. It's way too late. IS is just possible if you're highly skilled in this area, and this will take not only months, it will take a longer time. So really to work on these topics, to understand the tool stacks, to have some knowledge about all this, and mostly you need some kind of history as a security researcher, otherwise it makes no sense. So then left over for as a practical approach is Dust and Dust. So Dust, okay, you're quite late inside the supply chain of producing stuff because stuff must work or run already, and it has already some kind of complexity. So you spend a lot of money already. So the easiest and best part I would recommend is going over the SAS part, so static application security testing, because you can start with it. Even if you're writing the first code of line, you can start with this. Okay, so we have different abstraction layers. I don't want to go into much details, but Cloud Native is just an excuse. It's safe for monoliths. So Cloud Native is just because they have this the structure that they say we have some services talking together. And if you're thinking about, okay, what kind of tool can help me to make sure that this orchestration of microservices makes sense, to say the truth, all domain specific things, you have no tool that will help you. So you have to decide how to split up in microservices, what information is going from A to B and all this stuff. So, and make sure that the concept is secure. So there you are talking about security as a concept or security concept phase. So this is done by humans, and tool support is mostly crap. If you're talking about the API connection layer, so it means now this microservices start talking to each other, you are on a little bit more technical level. So because you can encrypt the whole communication between, but you have no tool support in terms of if I'm sending these two values together over the wire, it's less secure than sending this one A and then sending B, or using different channels. So there's not really tool support for this, because you need domain specific knowledge to make sure that the whole business process not be able to be compromised, but the communication itself, so encrypting the channel, handshaking, all this stuff, tools are good. So they are working on it. Going to the container-based infrastructure, yeah, that is something. So the whole orchestration, managing the pods and all this stuff, tools can start help you very, very, very much. So really identifying, is there different loads, and is there some mismatch inside the balance, and so circuit breakers, so all this stuff. So tools can start helping, definitely. But the biggest support you can get is inside your DevSecOps environment. So during the time you're coding, tools are here on a pure technical level, and the domain-specific things are not so dominant. So it means the tools can really help here on mathematical-based fundamental things. Okay, so that's one thing where you should focus on, is really on your supply chain where you're coding. We have polyglot environments, means we have to think about more and more hidden technologies that should be part of the security approach. One example is, for example, if you're coding with Vardin, Vardin is some sort framework where you can write something in Java, and the backend will trigger npm stack, and you have to make sure that you are not only scanning vulnerabilities in your Java universe where you're coding it, but in the end it's an npm stack-based web app that's coming out of it. So you need the whole lifecycle, it's a whole technology, it's a whole JavaScript environment in the back as well. And yeah, this is something. And well, so quite often I see that people say, oh, I don't care about all these layers. I'm just taking my Docker image and scanning it, and then I'm making this hard. And I can say, that's just crap. Why? So with every layer you are adding, there is no possibility that you're removing a vulnerability with a layer that's around. Okay, you're not able to remove something. It's just possible that you're making it not accessible. So mitigation and remediation information can be used to reduce a possible usable amount of attack vectors, but you're not able to remove a vulnerability. It's just not accessible. That's a huge difference. So with every layer, we are wrapping first our application. I'm adding some vulnerabilities with dependencies maybe, then they are there, even if I'm wrapping it or running it in operating system, then virtualization layer, and then the orchestration layer and Kubernetes and all this stuff. So with every layer, with every new technology layer, I'm adding vulnerability issues. By the way, if you're fighting against vulnerabilities, it makes sense to check license issues as well. Securing the process means that you're not only fighting against vulnerabilities and malicious packages, that's a big difference, but on the other side against stuff from the lawyer. So it makes no sense that I'm adding dependency that's running an Apache license, that's using something in Apache license, and this maintainer of the project don't care, and adding GPL license, okay, could kill your business. But of the whole tech stack, we have two dimensions. We have the domain-specific dimension and the technical one. The domain-specific means that here you have definitely something where you as a human has to decide, is this compromisable? This is a business part of it. But on the technical level, yeah, definitely tools can help a lot. But the most of you, sorry to say, but they are forgetting one big piece. They're hardening their own application, great, but they are forgetting their own infrastructure. Who of you hardened his Jenkins? Who of you checked if you don't have an Apple compiler? Who of you worked on this infrastructure part, or make sure that for release you have the corresponding compiler and JVM and all this stuff exactly in the build number you use again, and so on and so on. So make sure that the whole DevOps part is here as well, part of the security approach. So talking about different application layers, most common technologies, or normally all technology layers, have some kind of dependency manager. It means if I'm talking about an application, whatever programming language I'm using, I have a corresponding dependency manager that is accessing all this stuff from outside. Okay, that's coming because we have something like a coordinate, artifact ID, group ID, version numbers, whatever it's structured, and you have it on operating system as well, inside Docker, inside Kubernetes, everywhere. So you have this dependency managers that give you the possibility to manage all these external dependencies. And you should be aware of that in every layer, you have a huge amount of metadata that you can use for security approaches. So don't using this knowledge is more or less stupid, okay? So if you have all this information, I have a dependency that has a compile time dependency, has a test on runtime, statically linked, dynamically linked dependency, all this information, it makes sense to use it, not just using dump the binary, okay? But again, most people are forgetting the DevSecOps stack itself. So make sure that you're scanning your compiler, your Jenkins, and all this stuff against vulnerabilities. So why not? We at JFrog, we're doing this stuff for sure. This is why I'm talking about it, because we have solutions here. It's called the Artifactory. It's where all the binaries are stored with a meta universe. So it's you can use it. And this is one of the big let's say difference to other companies or other tools that are just looking at a binary. We have access to all this metadata over all these tech layers. And the part that is scanning it is called X-ray here. If you want to try it, there's a free tier. It's unlimited in time. It's just limited in the amount of space you can use, and in terms of what kind of vulnerabilities you see, because there's a huge amount of money that's worth this vulnerability for. But you have this free tier where you can start working for your projects, and then you have both tools so that you can work with this. Mostly, if I'm seeing here that people are talking on the management side and people are talking on the developer side, and they don't have, they're talking more or less about the same thing, the same mechanism, but using different words. Time to market means if you have a use case, you want to push it as fast as possible to production. Yeah, sure, everybody's aware, but then there's a requirement. Here's a vulnerability. It must be fixed in production. Why people are using a different process, a different speed for this? I never understood it. So the management gave you, okay, you have here this description of the use case, just implement it. If you think it's ready, just push it to production. It's your responsibility. Okay, you're doing it. You're optimizing it, making it as fast as possible. Perfect. Then there's a vulnerability. Oh my God, now we have to involve this person, that person. You need an agreement. You want to change dependency. Why this process is slower? It makes no sense. It should be the opposite. So make sure that you're talking with the management in a way that changing or getting rid of a vulnerability is like a use case. It should be done as fast as possible, must be automated as much as possible. So there is the same time to market. It's important with vulnerability, even more with use cases. Okay. Make or buy, don't reinvent the wheel. So it means the management's talking, okay, we don't have the knowledge, we are grabbing now external consultants. So we are buying this expertise, using this because we don't want to learn this by ourselves, blah, blah, blah. You know it. And what we are doing as a developer, we are doing exactly the same. For us, make or buy is, if I'm making it, I'm writing source code by myself. But mostly what I'm doing, I'm buying external dependencies. So I'm adding a dependencies is more or less buy as what we are doing as software developer. So I'm grabbing from outside. It's perfect, but it has the same challenge with external developers or external consultants. Yeah, they have more experience. They have done it a long time and they focus on this one, but I have to trust them as well. And the same we have with dependencies. We have to trust dependencies. How to get trust? Huh? So sometimes people are asking me, oh, I start with security. Now I'm checking my source code that I'm doing right things. And so, yeah, best practice, perfect. If you have resource allocation, all this stuff, make sure that's running well. But why you're not focusing on dependencies, because if I'm writing 100,000 lines of code, how many lines of code I'm adding as a dependency in my application? Mostly more, mostly. The same with the operating system. I'm writing a few configuration, grabbing tons of binaries, Docker statement even starts with a from statement, and so on and so on. And a dependency is, or what I'm getting from outside my whole tool stack. This is a binary. So I should focus on binaries because this is the most dominant thing of the whole tech layer stack. So this is really focus on your binaries. Please, please, please do it. Don't start with scanning your own source code. It makes no sense. It's a tiny piece in the whole thing. Okay. So, okay, compliance and vulnerabilities, we have different things. So depending on if you have to fight against compliance issues or license issues, make sure that someone is able to decide what's a good license, what's a bad license, and let the machine check. It's done perfectly, easily. Don't do it manually. Okay, it makes no sense. Don't do it manually. I see it's a few times and it's just crap. Okay. Vulnerabilities, okay, nobody has to define something. You have a high CVSS score, then you have to work against this vulnerability. So machine is scanning constantly, human has to do something. There is a big difference in handling stuff. So if you're talking about compliance issues, you have some component somewhere in the middle. The license is not good, so you have to get rid. You have to replace it with a semantic equal implementation, so you have to change it. This is not nice, but not so often you have to do it. With vulnerabilities, it's different. You have a same composition of dependencies, but in different composition of versions. And then you just have to work against a new version. But attack vectors can be combined. So compliance issues are just singular points, but vulnerabilities can be combined to different attack vectors. So you need the knowledge about all the different tech layers to see what different attack vectors are possible, because attacks are now fragmented, really coordinated, something on Java, something on Linux, something on Kubernetes, to make this on different places so that it fits to a big picture. I don't have time to talk about the lifetime of vulnerability, but you have different stages of vulnerability, and the short answer is the only thing what you can influence is the information about there's a vulnerability, it is available here, it is, until I'm changing it in production is where you should focus on. So automate the whole CI pipeline as much as possible so that you're not losing time, because until this information is public available and it's fixed in production, it's a high risk area, because information about the vulnerability is spread at most. Yeah? But if you want to see a little bit more, check out my YouTube channel. I have this description of the different lifeline steps of a vulnerability. It's very interesting to see what you can do in it, what stage you can do something. What is the biggest safety belt for you as a software developer? Okay, now I'm scared, so many things. And I'm not even talking about malicious packages. There's a different piece, okay? I'm talking about vulnerabilities right now. The bad thing you can do as a developer is you can have a very, very strong test coverage. So that's your biggest safety belt. So working with a good test coverage will help you. Changing things based on license issues, because you have to change it with semantic equal implementation. So you're grabbing in different dependency, different API, you're working against it, that's one thing. But on a daily basis, if you have to change the composition of versions of the same dependencies, if you have a strong test coverage, you can just update and downgrade versions. So fighting against vulnerabilities doesn't mean that you're always upgrading versions. Sometimes it's even better if you're up and downgrading a few components, because the full amount of vulnerabilities, and having in mind what an environmental metric is. So what is a CVS as compared, or seeing on my system environment, is better to have a mix on this up and down. And the big thing is really good, strong dependency management. I personally saying that pure line coverage and branch coverage just not enough. It's just a weak thing. Better is nothing. But I personally think that mutation testing is a very, very strong thing, because it's a very hard-bound line coverage to your code. If you want to know about mutation testing, maybe I'm here to show you mutation testing once, or check out my YouTube channel. I have a talk about mutation testing. It's an old thing, but it's really tough thing, and you can use it immediately in your daily job. So dependency management has the highest impact. Okay, that's really important. So executive order of cybersecurity. Why I'm now pushed to this stuff with SBOM and all this stuff? Well, the SolarWinds Hack was so strong that the US president had this executive order of cybersecurity. What this is, the US president's like the CEO of a company. He can't change the law, but he can say, tomorrow we are working with a different process or a different behavior. And this happened. So Mr. Biden, the US president, says every software that is used, owned, run, consumed by the US government has to fulfill this ASBOM. The software bills of material means you have to produce a full list of all dependencies of all tick lists to make sure that you're aware of what is running somewhere. Okay, that's something. Having in mind that everything is managed by dependency managers, yeah, you have this information, and it's cool to grab out from these dependency managers, because that's the single source of truth. Make sure that you're using fixed version instead of version ranges and all this stuff, because that's just crap. But here we know it since ages, not only because US president found out this is a cool thing. We at JFrog, we know it since a long time, but we don't call it ASBOM, we call it build info. But build info is a superset. So you have a special repository in Artifactory, repository types called build info. There you can collect all the information from building a binary. So metadata like library, agent number, date, time, whatever, all this stuff. And inside this immutable information for this immutable binary, you have one part that is dynamic, and that's X-ray data, so it's a vulnerability. So today, everything's green. I know this amount of vulnerabilities. The binary is checked, it's green, it's pushed to production, and the next day I'm not able to scan production because if I have a big customer, I can't touch production anymore. But I can see the binary I built yesterday is red today because with an update of the vulnerability database, we found out there are vulnerabilities, new knowledge. Then I'm aware of this, of the whole tech stack. So check out for the term build info. It's a superset of ASBOM. And it's easy to create. And out of build info, you can easily, with one click, create an ASBOM. So if you have the need to fulfill this ASBOM requirements, check out, you can generate it out of Artifactory easily. Okay, so I have done some stuff about it. I think depending on time, I have not enough time to explain it in detail, but check out my YouTube channel. So there's something, and we are slowly building this open source stuff, this buildinfo.org. It's still in progress. It's not final, but it's in progress. So have a look at it, and then you will see what are the concepts, what's an extension of ASBOM, and it will help you to not only to understand it, but really to do it for your open source project, for commercial project, whatever. Okay, supply chain security and development. Just have in mind the big picture. I'm not going through it again. Check out the project SALSA, SLSA. It's really good documentation projects that will guide you through all this, and have a look at this levels so that you can think where you are, what level you have from 0 to 4, and what are the next things. If you're interested, we just announced or started a core project. It's hardening for open source projects, a decentralized package manager. It's called Persia. It's addressing a bunch of these build threads inside this whole supply chain I showed you. So from building binaries until delivering. Well, it's short words is we have a build layer, we have a distribution layer, and build layer is grabbing the source code, building on multiple nodes, comparing the results so that you don't have compromised build infrastructure, and then pushing this binaries that are created to the distribution layer. It's a peer-to-peer network. And so you have more or less something like Maven Central, Docker Hub, and all this stuff, but in a peer-to-peer version. Authorities like Docker Hub and Maven Central will be integrated, so we have agreements with them already, and the whole source code is donated to the Linux Foundation, and soonish it will be a project of the Linux Foundation. It's not ready in this process, but the source code is already donated, and we have different companies like Oracle and I don't know who else is working on it. So it's not only done by JFrog, it's really an effort of different companies and persons. So if you have interest in blockchain and all this stuff, that's the way to go. It's really a cool project. So, okay, what can you do inside your IDE? Well, if you have the free tier, check out the IDE plugin and the CLI command. The IDE plugin will give you all the information straight in the IDE. So you're adding this first line of dependency, and you will get some graph like this. Then you see all transitive dependencies and see, okay, what kind of vulnerabilities are in. Is there a fixed version already? Yes, no. You can exclude it automatically and redefining the stuff. How this works, you can check here on my how-to. I have different videos that are showing how this process is done, so it's quite easily. And the main idea here is most people are pushing security inside the CI environment. And this is good. You have to do it, or you should do it, definitely. But the CI environment is way after you started coding. So you're adding a dependency, you start coding, maybe 1 or 2 hours, you're making your first commit, pushing it to CI. CI is complaining, vulnerabilities, compliance issues, whatever. So you lost already a bunch of time, and worst case, you have to redo your work. So I'm not motivated anymore. You're under time pressure. You wasted time already. So it makes sense to have this information straight in your IDEs for IntelliJ, VS Code, Eclipse, I don't know, all these different IDEs. Then you're adding a dependency, you see immediately the dependency tree, you see immediately what's going on, even without fetching the binaries, and that's a good thing. So you're declaring the dependencies and will get the information. You're not polluting a system with fetching vulnerable components, okay? And on command line, you can do it even with Docker image and all this stuff. So you're filling around, creating a Docker image and saying, okay, scan this Docker image on my machine, with the knowledge of X-Ray. And the same is, we just announced this for Docker desktops as plugin, so you can do it with a graphically user interface. So long story short, make sure that you're using all the information that's available as soon as possible, even before you start working. And so it means really, with the first line of code, you should have all the information inside your IDE. So that's the best thing I can say to you. Okay, so I think I'm just in time. I'm not sure, I think 50 or 55, my slot is done.
Yeah, pretty good.
Okay, so let me check. So I was just talking. Do we have any questions? I see nothing here. And well, if
there are no questions actually. If any questions, last minute, people. And yeah, thank you so much, Sven.
Yeah.
It was a very nice presentation and having so much information and so much tools actually. I think we get so much insights from the presentation. Thank you so much again.
Yeah, welcome. And if you have any chance, we can do a live hacking, even if it is virtual. So we can just try out a bunch of this open source stuff. So feel free to think about this one. Yeah, otherwise, if there are any questions, Twitter, LinkedIn, YouTube, but no emails. Please don't write me emails. Emails is just a mess by me. Okay. Okay.
Okay. Now we will have a short coffee break, and after that we will continue with Shai, and he will explain us debugging in production. It's another tough topic like DevSecOps things. So let's have the break and come back like 5 minutes later. Thank you again, Sven. Bye-bye.
Okay, bye.